Hi everyone. So last chapter we learned about derivatives. So chapter 4 is gonna be the applications of derivative. So section 4.1, maxima and minimas. Big idea. Derivatives can be used to compute properties of the graph of a function. The location of an extrema of a function is where the derivative equals to 0. Where the derivative is undefined, or if the function is defined on a closed interval at the endpoints of that closed interval. So if I draw a picture here, okay, so let me draw it here. So if we have something like this, okay, so you can see here we have like a minimum, and here we have maximum. Here we have a local minimum. Here we have a local maximum. Here we have a maybe minimum. Okay, so what's special here? You can see the slope is 0. Here the slope is 0, but here because we have a corner, it's not differentiable. So the slope does the derivative does not exist. So here we also have a corner, so the derivative does not exist. And here this is at the endpoint of an interval. Okay, so today we're going to talk about more about of that. Big skills, you should be able to find the extrema of a function by calculating where the derivative is 0 or undefined, and by evaluating the function at its endpoints if it is defined on a closed interval. Okay, so let's talk about the definition. Absolute maximum and minimum. A function has absolute maximum, or we can call global maximum, at C if f of C is greater or equal to r of x for all x in the domain. Okay, so if I want to draw a picture like this guy is gonna be the absolute maximum. Okay, and then a function f has the absolute minimum or global minimum at C if f of C is less than or equal to f of x for all x in a domain. Okay, then this number f of C is called the absolute minimum value of f. Okay, so the picture would be like that. So this is absolute minimum. Okay, so we usually say we have absolute maximum at the x values equals to some number, and then the y value, we call them absolute maximum value. Okay, the same thing for absolute minimum. We say f has absolute minimum at x equals to c, and then f of c is the absolute minimum values. The absolute maximum and minimum values of f are called the extreme values of f. Next, we have the extreme value theorem. A function that is continuous on a closed interval AB has an absolute maximum value and an absolute minimum value of that interval. So, for example, here, if we have a closed interval like A, B, okay, and a function is continuous, you can see here we have an absolute maximum here, and we have absolute minimum here. For this picture, we have absolute maximum here, and then the absolute minimum is actually at the endpoint. Okay, and this picture, we actually have 2 absolute maximum and 1 absolute minimum. Okay, so this theorem tells us that if we have a closed interval, okay, and if the function is continuous, then we must have absolute maximum and absolute minimum in that interval. Okay, we'll first talk about these definitions, and then we will do examples. Okay, so examples can help us to understand the concept. All right, next, local maximum and minimum. A function f has a local maximum, or we can say relative maximum, at C if f of C is greater or equal to f of x, where x is near C. So the picture is we can have this. Okay, then this guy, okay, this guy is greater or equal to f of x, where x is near it. So this is a local maximum. However, this is not a global maximum because the global maximum is here. So a global maximum is also a local maximum, but not all the local maximums are global maximums. So we have to be very, very careful. Similarly, a function f has a local minimum or relative minimum at c if f of c less than or equal to f of x when x is near c. So if we draw a picture, so this guy is a local minimum. Okay? And however, it might not be the absolute minimum. In this case, we might not have an absolute minimum because if the function go down forever, then we don't have it. Oops. Okay. All right. Local extreme point theorem. If f has a local minimum or maximum value at c, then either the derivative is 0 or the derivative does not exist. Okay, so we have this picture. Well, you can see the local maximum. We have the slope is 0. Okay, slope of the tangent line is 0. And at the local minimum, we also have the slope of the tangent line is 0. But we might have like picture like this. Okay, then this guy, we have a corner, so the derivative does not exist. But we still have a local maximum there. Okay, so that's why we mark. 1. The converse is not true. When the derivative is 0, f does not necessarily have a local maximum or minimum. For example, the cubic curve. You can see here at this point, the derivative is 3x squared is 0 at x equal to 0. Okay, but however, this is neither local maximum nor local minimum. Okay. Second remark, sometimes the derivative does not exist, but the point could be a local maximum or minimum. For example, this absolute value of x, you can see the derivative does not exist here because the left side derivative is, the slope here is -1. And the slope here is 1, so they don't match as 0. So f is not differentiable at 0. Okay? But it has a local minimum. Actually, this local minimum is also a global minimum. Okay? The feeling is like, okay, we have the tallest students in our class, but he might not be the tallest students in the whole Indiana Tech. Okay? Same thing, we have the shortest students in our class, but however, he or she might not be the shortest student in the whole Indiana Tech. Okay? So that's the relationship between global maximum and local maximum. Okay, next important concept, critical point. A critical point of a function is a number in the domain such that either the derivative is 0 or the derivative does not exist. So it has 3 important points. First, it must be in the domain. Second is either derivative is 0 or the derivative does not exist. Okay, keep this in mind. Okay. Example 1. Find the absolute maximum and absolute minimum for the following functions. Okay, the first one. Do we have absolute maximum? No, because it goes up forever, so no absolute maximum. Do we have absolute minimum? Oh, it should be this point, but do you see an open circle there? So it's missing. It means it's missing. So no absolute minimum. How about this guy? This one is the absolute maximum. So absolute maximum at x equals to 2. This guy is the absolute minimum at x equals to 1. So I strongly recommend you to pause the video and try the problem first. Okay, so here, because that point is missing, no absolute maximum. That point is missing, no absolute minimum. Oh, here it goes forever, so no absolute maximum. Go down forever, no absolute minimum. Okay, how about here? Well, okay, so if everybody in our classroom with the same height, what do you say? Everybody is the tallest and everybody is the shortest. Okay, so that's why in this example, absolute maximum is or x values, okay? Or the points, so all x, all numbers, okay, all x values. And also absolute minimum, okay, maybe it's better to say at or x values. Okay, next, what's the tallest guy? Oh, it's missing. So be careful, the tallest guy is not this point, no. Okay, the tallest guy is missing, so no absolute maximum. How about the shortest? The absolute minimum is this guy, right? Not this one, be careful. Okay, so absolute minimum at x equals to 2. All right, how about this guy? Oh, this one, the point is missing. Okay, missing, so we have no absolute minimum, and this point is also missing, so it goes up forever, so that's why I have no absolute maximum. Okay, all right, let's continue. Alright, so let's work on this example. Okay, let me use a marker here. Okay, so find the critical points of the following function. Okay? Alright, so what are critical points? Remember, for steps, we're gonna take the derivative here because we have products. So we have product rule. Is the derivative of the first guy times second guy plus first guy times the derivative of the second guy. Okay, what is the derivative of x squared? That's 2x. What's the derivative of ln of x? 1 over x. So we have 2x ln of x plus here we can cancel, so we have x. Remember, to find critical points, it means either the derivative is 0 or the derivative is undefined. Okay, so if we want to solve like when is the derivative 0, so you try to factor as much as possible. So here you can see we have a common factor x, and after we factor out x, we have 2 ln of x plus 1. And so we can set it equal to 0. So this factor gives us x is 0. This factor gives us 2 ln of x plus 1 is 0. 2 ln of x is minus 1. ln of x is negative 1/2. X is both sides raised to the power of e. Okay, so we actually have 2 points. Okay, but however, what is the domain? What's the domain? Remember that 3 special functions with restricted domain? Okay, what are those? First, square roots. What do you need for square roots? You need a greater or equal to 0, 2 fractions. What do we need? Denominator not equal to 0, and 3 our natural log. What do we need? Greater than 0. Okay, so in this problem, we have ln of x, so we have x greater than 0. Oh, you can see now x, what happened? This guy is not in the domain. So it is not a critical point. To be a critical point, it has to be in the domain, and then either f prime is 0 or the f prime does not exist. Okay, so that's why we can say that like a second step, you set it equal to 0 and then you solve for the roots, and then the third step, you figure out the domain. Okay, so the critical point is x equals to e to the negative 1/2. So actually critical points, and also another name, critical numbers, they means the x values. So that they're not asking the points, okay? They're actually asking the x values. Okay. All right, let's continue. So first steps, we take the derivative. Derivative of 2x is 2. Derivative, let's make it into the standard form. This is 2 to the, what? 2/3, right? When we differentiate, we put the exponent down in front and we subtract 1 to it. So negative 1/3. Okay, so what is that? Well, that means x to the 1/3 is in the denominator. And then when we take the common denominator, 3x to the 1/3, we actually get 3x to the 1/3 plus 1. Okay, you see what I'm doing? Because I see there's a common factor 2. I factor out the 2, and then this is like 1 times 3 to the 1/3 is 3 to the 1/3 plus 1. Okay, so this is a fraction. Okay, so fraction, wow, remember we can have f prime is 0, or we can have f prime is does not exist. Okay, all right, so f prime is 0 means the numerator of f prime is 0. F prime does not exist. It means the denominator of f prime is 0. Okay, so here numerator is 0, so we have 3x to the 1/3 plus 1 is 0. 3x to the 1/3 is minus 1. X to the 1/3 is negative 1/3. And what is x? We cube both sides. Negative 1 cube is still negative 1. 3 cube is 27. When the denominator is 0, so 3x to the 1/3 is 0. That's the same as x to the 1/3 is 0. So what is that? 0. Okay, let's look at our domain. So this is like the second step, right? Let's look at our domain. Our domain, do we see square roots? No, we have cube roots, but cube roots is okay. Do we have fraction? No. Do we have natural log? No. So what do you say about the domain? All real numbers. So that's why we say the critical points are x equals to negative 1/27 and x equal to 0. So we have 2 critical points. Okay. All right, let's look at one more example. So first step. So it's good that if you still have your recipe sheet, you can put this down in your recipe sheet. Okay. So the first steps, we compute the derivative. The derivative, let's make it into the standard form. So it's negative x to the negative 2. Okay, so we have numerator and denominator. The numerator won't be 0, so we can have like set the denominator is 0. So then x is 0. So this actually corresponds to f prime does not exist. Okay, but 3, what is the domain? Domain, we have fractions, so x not equal to 0. See, this guy, is not in the domain. Do we have critical points? No, so no critical points for this problem. Okay, so you have to be careful. All right. So procedure for finding absolute, maximum, and minimum values. Okay. So next we want to we learn how to find the critical points. Next we're gonna find absolute, maximum, and minimum values. So first let's assume f is continuous on a closed interval a to b. Okay. So and what do we do? So let's say we have interval a to b is closed. Okay. Let's say the problem look like this. What do we do? First, we find the values where we find the critical points. Okay, we find the critical points, and then we find the values at the endpoints. Okay, so we plug this point into f, we get f of a, and then we plug the critical points in f, we get f of, let's say this is c, and then this is f of b. Okay, so among those values, the biggest one is going to be the absolute maximum value. The smallest one is going to be the absolute minimum values. Okay, so this is how it works. So let's continue with example 3. Find the absolute maximum and minimum values of f of x. Okay, so the first step, we compute the derivative. What's the derivative of that? Well, 2 times 3 is 6. So we have 6x squared. 2 times 15 is 30. And then this is 36, right? Okay, remember our goal is to factor as much as we can. We see a common factor 6. Then we have 5x plus 6. Okay, so I strongly recommend you to try the problem first and then continue to watch the video. Okay, how do you factor it? Yes, minus 3 and minus 2. So we want to set it equal to 0. We get x is 3 and x equals to 2. Okay, and then what are the endpoints? So the endpoints is 1 and 5. Okay, so let's plug all of the endpoints into f. Let's plug all of the critical points into f. So what's f of 1? See, we plug in our f. So that is 2 times 1 minus 15 times 1 plus 36 times 1. 2 minus 15 is negative 13. Okay, then 36 minus 13 is 23, right? Okay, so this is 2, 5 cubed. What's 5 cubed? Is actually 125. Minus 15, 5 squared is 25, plus 36 times 5. What it is? So you can actually plug this in your calculator. Okay, you can use calculator for this part. So the answer is 55. F of 3, what is f of 3? Okay, f of 3, we have 2. 3 cubed is 27. 3 squared is 9. 36 times 3. Okay, you can also plug this in your calculator and you will get 27. Okay. F of 2 cubed is 8. 15, oops, minus 15. 2 squared 4 plus 36 times 2. Okay, so plug this in your calculator. What do you get? We have 28. Okay, which one is the biggest? Oh, this one. Okay, so we have absolute maximum at x equals to 5. And the absolute mass, the absolute maximum value is 55. Which one is the smallest? This one. So we have the absolute minimum at x is 1. Okay, and the absolute minimum values is 23. Okay. All right, let's continue to the next problem. Okay, so you can try to work on this problem first, and then let's continue. So the first step, f prime, okay, we take the derivative. So that's 4 over 3 x to the, you subtract 1 from the exponent, we get 1/3, right? Next, 1/3, we subtract the exponent, okay, subtract 1 from the exponent, we get negative 2/3. Okay, what is that? You can see here we have 24 x to the 1/3 over 3. But here, can you see the negative exponent? It means it actually lives in the denominator. You gotta do that because you want to simplify it. Simplify means you want to if it's fractions, you want to combine into a single fraction. So let's combine into a single fraction. Okay, and then what do we get? How do we get this common denominator? So we use x to the 1/3 times x to the 2/3. That will give us x minus 1. Okay, so we have numerator and denominator. Okay, by making the numerator 0. Okay, let me put one more step so you can see it clearly. By making the numerator 0, we actually corresponds to f prime is 0. By making the denominator 0, we actually correspond to f prime does not exist. So here we have x to the 1 over 24. Here we have x is 0. Okay, so let's look at our functions. Okay, so look at our interval. So our interval is -1 to 1. By the way, this is cube roots. Cube root is okay. Cube root, the domain is all real numbers. Okay, that's why -1 is okay. So let's check the endpoints, -1 and the 1. Our critical point are 0 and 1 over 24. Okay, all right, we plug in -1, we plug in -1, -6, -1, cube roots. So don't plug this in your calculator because your calculator for the roots, okay, the root functions, it only works for positive numbers. So you're not able to plug in negative numbers for the roots, even though it's cube root of square roots. You're not able to do that. But we know cube root of -1 is still -1. But then -1 to the 4th is 1. Okay, so we have 6 times 1 is 6 minus cube root of cube root of -1 is -1. So the answer is 7 here. Okay, what happened if we plug in 1? We have 6 minus 1 is 5. What happened when we plug in 0? Yay, we get 0. Those are easy. Okay, but next, we get 1 over 24 to the 4/3 minus 1 over 24 to the 1/3. Okay, let's plug this in your calculator. So I really hope that you can pause here and try to plug this in your calculator, because sometimes if you don't plug this in your calculator, you don't know like the difficulty of using the calculator. It's like sometimes students ask me during the exam saying, "Oh, why my calculator says error?" Because you make a mistake, but I cannot tell you what is wrong. Okay, so I cannot answer you some questions like that in the exam. Okay, so please everybody try to plug this in your calculator and you get approximately minus 0.26. Okay, so which one is the biggest? 7 is the biggest, so we have absolute maximum at x equals to minus 1. This is the smallest, so we have absolute minimum at x equals to 1/24. And also, the absolute maximum value is 7. The absolute minimum value is 1/24. Okay, so that is example 4. Let's continue. Find the absolute maximum and minimum values for this function. Okay, first, f prime of x is derivative of 3x to the 4th is 12x squared. Derivative of 4x cubed is 12x. Oh, did I make a mistake? Yes. This is 3, this is 2. Okay. And minus 2 times 36 is 72x. Okay, do you get that, everybody? Remember, we want to factor it completely. What is the common factor? Yes, so let's continue. We have x squared, we have x. What is that? Actually, 6. Okay, let's continue to factor it. So x, negative 2 plus 3, right? We set this equal to 0. And then what do we get? We get x is 0, x equals to 2, x equals to minus 3. Okay, everybody? And second. Okay, so this is our critical points. And then let's look at our interval. So which value is on the interval minus 2 and 3? So sometimes we might have a lot of critical points, but because we're only looking at the interval from minus 2 to 3, so this is not in here, so not in there. So we don't consider that one. Okay, so f of the endpoint, negative 2 and 3. The critical points are 0 and 2. So plot this into the function. 3 negative 2 to the 4th is 16. Negative 2 cubed is negative 8. Negative 2 squared is 4. So put this in your calculator. You get minus 128. When we plug in 3 to the 4th, 81. 3 cubed, 27. 3 squared, 9. Put this in your calculator. You will get 27. And then when you 0, oh, that's nice. Just 0. We plug in 2 to the 4th, 16. 2 to the 8 is, 2 cubed is 8. 36, 2 squared is 4. Okay, so put this in your calculator, we get minus 64. All right, what is the smallest? So the smallest value is this guy. So this is absolute minimum at x equals to negative 2. Here, which we want the biggest? This is the biggest. So absolute maximum at x equals to 3. So yeah, so the absolute maximum value is negative 128. The absolute maximum value is 27. Okay, so if you want to know what does that mean, so actually you can draw some picture. So here negative 2 is here, like 3 is here, 2 is here, 0 is there. So it passed through negative 2 and negative 128 is so negative. Let's say this is negative 128. And at 3 is like 27. Okay, and then at 0 is 0, at 2 is negative 64. So maybe here is negative 64. So connect them smoothly. Okay, so this is what it looks like, roughly. Okay, if you want to sketch the picture, this is what it looks like. So far, so good, everybody. Okay, so that's it for this video. So see you. Bye.